Hi Year 8, this is another video on chemistry which will help you with your revision and your preparation for your second summer assessment. But this will help everyone actually that's watching this video. It is on compounds and acidity in Key Stage 3. So in your book it's on page 80, 9.2, compounds and acidity. Just a bit of background. So here in the UAE we burn a lot of fuels. And when those fuels burn, the chemicals in them react with oxygen in the air. And the oxides rise into the atmosphere when they react, and they dissolve in rainwater. And many of these oxides are formed with non-metal elements. So when this happens, the resulting solution is catastrophic, potentially catastrophic for the environment, for stonework, for masonry, for soils, for ecosystems. It's acid rain. Okay, it can strip the bark off trees and it can acidify the soils, and that can really destroy ecosystems because there are animals in the food web in the ecosystem that depend on soil life, the insects that are in soils, and plants also depend on being able to grow in certain pH ranges. So, just a quick summary of the different themes. The first thing that we're going to look at are the reactions of oxygen with elements. So not only do hydrochloric acid and nitric acid and sulfuric acids, not only are they the chemical compounds that we know that form solutions with a pH that's less than 7, we also have oxides that can form. Oxides, a group of compounds called oxides, are formed when substances react with oxygen, and those can actually exhibit acidic behavior, and they can also exhibit alkali behavior as well if they dissolve in water, okay, or basic behavior if they cannot. So, reactions with oxygens. Reactions with oxygens can be divided into two sections. Let's have a look at the metals first. The metals can react with oxygen in the air readily when heated. There's a nice example showing that to you in the labs, and many of you will be able to remember it. Did this in the fume cupboard. There's the word equation at the top in that box. Magnesium plus oxygen reacts to form magnesium oxide. This is called a synthesis reaction. It's a synthesis reaction because you have the direct combination of two of the elements together, magnesium combining with oxygen to form magnesium oxide. Notice that the oxygen actually has a 2 on it, and that's because oxygen exists as a diatomic molecule. We have covered diatomic molecules this year during distance learning. So oxygen is a gas as well, so remember in simple equations, balanced simple equations, you have to have the state symbol there as well. Okay, so that's your oxygen to O2, which is a gas. In order to be able to balance the formula of MgO, which is magnesium oxide, we have to have a second magnesium to combine with the second oxygen here. So the formula of magnesium oxide is MgO, but we have two pairs of MgO solid forming because we actually start off with 2 atoms of oxygen in this molecule, and you have 2 atoms of magnesium that need to react, 1 for each of them. So here is a typical method of creating magnesium oxide by heating magnesium in air. It's lovely. I've seen it so many times in the lab, and I've tweeted it also on the Twitter at @nightbusci. Quick plug there. Okay, fantastic pictures on there. Right. The magnesium is there. It's crucible. So this is a crucible. It's just like a ceramic pot, and it's a pipe-clay triangle to keep it balanced because the crucible would otherwise fall through the tripod triangle. You've got your Bunsen burner there, and you've got your heat-proof mat. Okay. So the second type, so that's the first type of oxides that can form, and if a metal oxide forms, you can actually do chemical reactions with it. You will actually find that metal oxides neutralize acids. Okay. So the second type of oxides that form are oxides that form with non-metals, and non-metals can also react with oxygen in the air when they're heated. Okay, so we have sulfur plus, there's 2 examples, sulfur plus oxygen reacts to form sulfur dioxide. This is a balanced chemical equation. Make sure you memorize these chemical equations as well. You've got carbon and oxygen reacts to form carbon dioxide. So again, You've got the O2, but in each of these examples, sulfur and carbon exist on their own. And it just so happens that you only need one carbon and one sulfur to form those respective dioxides. Why are they called dioxides? The reason why they're called dioxides is because in a molecule of these oxides, each molecule contains 2 atoms of oxygen. Okay. Now these are gases. So you'll notice that we had a solid forming before, but now we've got a gas. So solids tend to form when you have metal oxides, and gases tend to form when you have non-metal oxides. So a little bit of a clue. Okay, I've done this type of reaction in class. I've tweeted lots of pictures on it, but you've seen this as well with things like barbecues, coal, which is a form of carbon, burning in oxygen to form carbon dioxide. Now, when we look at the periodic table, you can actually see a nice little trend. We can actually see a little pattern. There's your staircase. That's your staircase. So everything on the left-hand side of this is a metal, everything on the right hand side is a non-metal. We just tend to find, you can see that there's an odd example here, which is germanium, because these elements over here tend to have properties of both metals and non-metals. But you can actually see that the research has been done for you in this, and the results are in your table right in front of you. These elements tend to form acidic oxides. So we've got boron, carbon, nitrogen, fluorine, silicon, phosphorus, sulfur, chlorine, bromine, selenium, astatane, and germanium, okay, all seem to form acidic oxides. Whereas these ones over here, in group 1 and 2, lithium, sodium, potassium, remember potassium's with a K, magnesium, calcium, remember sodium, by the way, is with a capital N, little a, must be a little a, okay? These tend to form basic oxides, okay? So in terms of acidity, oxides tend to form from metal elements that have, and when they have that reaction taking place, you find that those oxides have pH values that are greater than 7. So these, when they dissolve in water, they give you pHs that are greater than 7. Now the reason why is because they tend to sponge up all of the hydrogens that are inside water naturally, leaving the OH minuses, which are hydroxide ions. Now, some of these will dissolve in water, forming forming alkaline solutions. Others may not dissolve so much. They're not very soluble in water. Calcium hydroxide, for example, is sparingly soluble in water, but they will react with acids. Okay, so oxides formed from non-metal elements will react with water to form acidic solutions with pHs less than 7. So these are pHs greater than 7, and they will neutralize acids whether they dissolve in water or not. These ones over here, these non-metal elements, the oxides from the non-metal elements, they will react with water to form acidic solutions with pH less than 7. And it's these acidic gases that react and dissolve in water to form acid rain, okay? So I did say that there are some elements that are kind of in between the behaviors. They can't decide whether they're going to behave like metals. They can't decide whether they're going to behave like non-metals. Aluminium is a great example, okay? Aluminium is a great example where it will react with both acids and alkalis. So the top line over here is how it reacts with an acid, a typical acid, hydrochloric acid, forms aluminium chloride plus hydrogen. That relates to the reaction of acids and metals. So I've just done that video on the channel. Here is also how it reacts with sodium hydroxide. It's a very strange product. It's called sodium aluminate, but it does react. Okay, so the aluminium oxide does react, and it forms something called sodium aluminate and water. And this sodium aluminate will actually dissolve. Now, the third point I would like to make is about the reactions of acids and metal oxides. So here we have a typical one. Just did a video on the reactions of acids, and this is a metal oxide, so it's magnesium oxide, and it forms a salt. Magnesium sulfate is the salt that forms, and you have water. So this is actually a type of neutralization reaction. It's classed as neutralization because the acid particles here, the positive hydrogen ions, these hydrogens, they will combine with oxygen to form water. And the definition of a neutralization is a reaction that forms water by combining hydrogens with a source of oxygen. Okay, so as this is a metal oxide that is a solid, you can try to dissolve it in water, but it's very, very stubborn. It doesn't really dissolve with water at all. Nevertheless, it will still react with an acid to form a salt and water, and this can then be classed as a base because it's a neutralizer of acids. If you have a base that is soluble in water, that is classified as an alkali. It's still a base, but it's classified as an alkali. So that's what this is basically telling you. Some metal oxides, such as magnesium hydroxide, are insoluble. They are called bases. So in practical terms, these reactions will often be heated up to speed up what's otherwise a very slow reaction. Okay. The reason why is because the base will not dissolve in water, so it's all to do with surface area. Now, the great thing about a base is that you can easily see when the acid has completely reacted, and we're going to look at that in the next video. So quick questions. Let's see if we can do those. So here are some of the questions that I'd like you to think about. What would you call the substance with the formula CaO? Pause the video. The answer is calcium oxide. Predict the pH of sodium oxide. Explain your choice. Pause the video. Or sodium oxide rather is so sodium oxide is something that comes from sodium, which is on the left-hand side. The acidity of oxides with metals on the left-hand side is a basic oxide, so the pH would be greater than 7. Number 3, predict whether bismuth oxide would actually be acidic or alkali. Pause the video. Okay, so what you would have to do is you would have to find out where bismuth is in the periodic table. If bismuth is on this side of the periodic table, on the left-hand side, then it would be an alkali. If bismuth oxide was on the right-hand side of the periodic table, it would be an acidic oxide. Number 4, is sulfur dioxide more likely to react with sodium hydroxide or hydrochloric acid? Pause the video. So the answer to this is all to do with the fact that the sulfur dioxide is an acidic gas. It's acidic because it comes from a non-metal. Okay, so sulfur plus oxygen reacts to form sulfur dioxide. So acids don't tend to react with acids. They tend to react with bases to form water, and that's a neutralization reaction. So as sodium hydroxide is an alkali solution, I would predict that the sodium hydroxide would be the chemical that reacts most likely with sulfur dioxide. Sulfur dioxide will form a neutralization, will conduct a neutralization reaction with sodium hydroxide. So the answer is sodium hydroxide. Let's think about the last question. When nitrogen gas reacts with oxygen in the air, several different nitrogen oxides can form. Write the balanced symbol equation for the formation of nitrogen oxide and predict the pH of this gaseous oxide. Pause the video. So nitrogen is a diatomic molecule, so it would be N2 plus O2 reacts to form, arrow, 2NO. And because this is on the right-hand side in the periodic table, we would predict the pH to be less than 7 because it is acidic. Good luck with your revision. I hope that was a nice whistle-stop tour of one of the topics that you need to revise year 8. And for anyone else that's watching, I hope that really helped you understand a little bit more about compounds and their acidity. Watch the other videos that I'm doing right now, which are going to be helping the year 8. The next video that I'll be doing, which I hope to see you in, is talking about atoms and molecules in neutralization. Great topic. I love that topic because it talks about hydrogen ions and what actually happens when you have an acid and alkali substances when you have hydroxide ions. So click on the next video, like and subscribe. Best of luck, year 8s. Keep revising. Take care. Bye.